Let n be the positive integer 777,777, a 313-digit number where each digit is a 7. Let f of r be the leading digit of the rth root of n. What is f of 2 plus f of 3 plus f of 4 plus f of 5 plus f of 6? An important thing to note for this problem is, for example, if we have the number 384, and you divide 384 by 10, you get 38.4. And if you divide 38.4 by 10, you get 3.84. In each of these cases, 3 is the leading digit. So whenever you divide by 10, the leading digit doesn't change. So for example, let's say we'll start with the second root of this. And what we can do here is that this is going to be, if we do, this has the same leading digit as this. And this is equal to still in the parentheses, 100 in the square root. So when we do something like that, this now becomes 777.77. And here, with this, since it started with 313 digits, we divided by 100 within the square root. This has 309, 311 digits. And so with that, we can keep dividing by 100 in the square root, and the leading digit of this will never change. So if we keep dividing by 100, suddenly it has 313, 311. We can get all the way to 3, down to 1 digit. And so then what we have in the square root is going to be 7.777777. And this number has the same leading digit as the original number we were considering. And so the leading digit of this, well, this is in between root of 4, which is equal to 2, and root of 9, which is equal to 3. So therefore, the leading digit of this is 2. So f of 2 is equal to 2. And we can repeat this process just for all of the leading digits. So we'll go with the third root. So here we have 777 to the third root. And in here, we need to divide by 1,000. That is then equal to this. So when you divide this by 1,000, the digits go 313. Then this next one would have 310, and you'd follow this pattern. Since it goes down by 3 every time, 3 actually goes into 312. So this would go all the way down to 1. So same deal, you would end with 7.777 ... third root of that, and that is in between cube root of 1 and cube root of 8. That's equal to 2. That's obviously equal to 1. So f of 3 is equal to 1. Now onto the fourth root. So now you get the pattern by this point. We were dividing by 1,000 there. This time we need to divide by 10,000. So I'll skip right to when you divide by 10,000, it goes from 313 digits to 309 digits. And again, 4 goes into 312. So then this is going to go all the way down to 1. So again, in this case, we'll end with this 7.777, a 1-digit. The fourth root has the same leading digit as our original. And so this is in between 1 to the fourth root and 16 to the fourth root. That's equal to 2. It's equal to 1. So f of 4 is equal to 1. Now onto the fifth root. So now this time you need to divide by 100,000 to get that root divided by 10. So now the digits are going to go from 313 to 308. And 5 goes into 310. So this is going to go down to 3 digits. So we can get it down to 3 digits here. So this is going to be 777.777. So we need to find out the fifth root of that. Well, that's in between the fifth root of 243 and the fifth root of 1024. That's equal to 4. This is equal to 3. So the leading digit here is going to be 3. So f of 5 is equal to 3. Lastly, the sixth root. 6, it's going to go 313. We need to divide by 1,000,000 to get divided by 10. 313, 307. And 6 also goes into 312. So this is going to go down to 7 and 1. So we'd have 7.777. Sixth root, that is in between sixth root of 1 and the sixth root of 64, which is 2. It's equal to 1. So f of 6 is equal to 1. So therefore, now that we've found out all these values, it's going to be true that f of 2 plus f of 3 plus f of 4 2 is equal to 2, f of 3 is equal to 1, f of 4 was equal to 1, f of 5 was equal to 3, and f of 6 we just found was equal to 1. So 2 plus 1 plus 1 plus 3 plus 1 is equal to 8, which is the value we were trying to find. So going back up here, that sum is 8. So the answer is choice A.